Hi, I am Shyam Karnagallu. I am a scientist at Institute of Nanotechnology at Karlsruhe Institute of Technology. I primarily use atom probe tomography in my research, and today I will show you atom probe tomography. In atom probe tomography, our specimens are made into really sharp needles whose end radius is less than 100 nanometers, and the specimen is cooled down to temperatures less than 70 Kelvin. A high voltage in the range of 1 to 10 kilovolts is applied by a counter electrode. And the consequence of this small end radius and the high voltage is that on the surface, a really humongous electric field is generated, which is in the order of 10 power 10 volts per meter. Because of this huge electric field, the electrons in the surface atoms get drained, and the electrons are finally moved into the metal itself, converting the atom into an ion. This process is called field evaporation. And this ion now gets repelled towards a position sensitive detector on which the detector XY positions are recorded of the impact of the ion. The evaporation is controlled so that time of flights of the field evaporated ions can be measured by using a laser pulse or a high voltage pulse. By pulsing these two evaporation triggers, we can measure the time of flights, which forms the basis for mass spectrum discrimination. So in effect, atom probe tomography is a time of flight mass spectrometer in combination with a sub-nanometer spatially resolved projection microscope.
As I said, for atom probe, we need samples which are in the nanometer size. So we usually make these samples through electropolishing or focused ion beam preparation. And we usually have our samples on top of this silicon coupons. So here, there is a silicon coupon which is loaded onto a puck. And the silicon coupon you can see here. And usually we load this coupon into a carousel, which I will show you next. And these are the electrodes which we use for the analysis. So this is the carousel which I was explaining you about. And we usually load our samples onto this carousel. And we load them like this using a puck manipulator. Once this sample is positioned and locked into our carousel, we load this into the load. So once we have loaded our sample onto the carousel, now we will move the carousel into our atom probe's load lock. So this is the load lock of our local electrode atom probe. This is the version LEAP 4000XHR from Kaneka. And the load lock is the only chamber of our atom probe which sees the atmospheric pressure. And then it is pumped to the pressures of 10 power minus 6 to 10 power minus 7 torque using this turbo pump. This chamber is separated with the buffer chamber, which is here with this particular valve. And the buffer chamber is usually in the pressures of 10 power minus 8 to 10 power minus 10 torque, and it is pumped by using a pump which is on the back side. Now the buffer chamber is separated with the analysis chamber, which is here, by this particular wall. And the analysis chamber itself is at a pressure of 10 power minus 11 torque, and it's pumped by an ion pump. And the analysis chamber is equipped with a voltage pulsing unit and a laser pulsing unit. The laser pulsing unit is at the back of this analysis chamber, and the voltage pulsing units are at the back of the instrument. So we moved our sample from the load lock to the buffer chamber. Now the load lock carousel itself was moved to the buffer chamber using this vertical manipulator. And now we are going to move the sample from the load lock carousel to a buffer carousel. So we have another carousel because we don't want to expose the buffer carousel to the atmosphere. So in order to move the sample from load lock carousel to the buffer carousel, we will use this horizontal manipulation rod. And while controlling the movement of the carousels themselves using this vertical rotation of the manipulation rod. Now that our sample is inside our buffer carousel and in buffer chamber, and we waited for the pressure to get good so that we can open the valve between the buffer chamber and the analysis chamber. Now to move the sample from the buffer chamber to the analysis chamber, we use the horizontal manipulation rod, and we lock in our sample and move it to the analysis chamber. And inside the analysis chamber, the pressure is around 10 power minus 11 torque, and we cool our sample using this cryo head And this is the cryo head which compresses helium so that it can cool down the sample to temperatures of 30 to 40 Kelvin. And this is the guy which is making those rhythmic noises. So after atom probe analysis, you basically get a 3D virtual volume of all the atomic positions with a sub-nanometer spatial resolution and with all the chemical identities, which allows you to do different sorts of analysis which can address a wide range of materials problems.